Okay. So the first problem is an analog signal is given by x of t, which is 30 cos 50 pi t plus 10 sine 300 pi t minus cos 100 pi t. So here we have to calculate the Nyquist rate. Here we have 50 pi t, 300 pi t and 100 pi t. So for the given sample frequency component are f1, which is nothing but half of 50, that is 25 hertz, and f2, which is half of 300, that is 150 hertz, and f3, which is nothing but 50 hertz. So the maximum frequency FM. Among this, which one has the maximum frequency? F2 have the maximum frequency. Maximum frequency is FM, which is nothing but F2, which is 150 hertz. So what will be the Nyquist rate? Anyone? Nyquist rate is FM, Fs. So Fs should be equal to Fs is nothing but 2 times Fm. Here, yeah, right, 2 times Fm, which is nothing but 300 hertz. Is this clear? Is this clear? So now we will learn about the reconstruction filter. A reconstruction filter is nothing but a low-pass filter. This low-pass filter, reconstruction filter is nothing but a low-pass filter. This low-pass filter is used to reconstruct the original signal from the sampled signal. That is, here reconstruction filter is nothing but an ideal low-pass filter. It is used to reconstruct the original signal x of t from the sampled signal g of t. Is this clear? This is also known as interpolation filter. So, reconstruction filter is also known as interpolation filter. It is nothing but a low-pass filter. It is used to reconstruct the original signal from the sampled signal. That is, we have to reconstruct the original signal x of t from the sampled signal g of t. In order to reconstruct the original signal from the sampled signal, we use a low-pass filter known as interpolation filter or reconstruction filter. Now we will learn the reconstruction formula or the interpolation formula. Interpolation is nothing but the process of reconstructing the original signal, that is the continuous time signal, from its sample is known as interpolation or reconstruction, and it is achieved by passing the sampled signal g of t through an ideal low pass filter. So sampled signal g of t is passed through an ideal low pass filter, otherwise known as reconstruction filter or interpolation filter. This ideal low pass filter has a cutoff frequency of FM hertz. That is, this is band limited to minus FM to FM. All the signal which lies between minus FM and FM are passed. All other signals, all other frequency components which comes beyond this frequency range are avoided or excluded by this ideal low pass filter. So, in last class, in sampling theorem proof, we have discussed about the g of t. G of t is nothing but 1 by Ts into x of t plus 2x of t cos omega s of t plus etc. Is the board clear? Okay, in last class, we have discussed about the expression for g of t. G of t is nothing but 1 by Ts into x of t plus 2 cos 2x of t cos omega st plus 2x of t cos 2 omega st plus etc. Here, the sampled signal contain, that is g of t contain the components 1 by Ts into x of t. That is, a sampled signal contain the component 1 by t into x of t. This sampled signal must be passed through an ideal low pass filter of cutoff frequency FM hertz and gain Ts. That is g of here g of t is nothing but x of t into impulse train, that is original sampling theorem, that is original continuous time signal into impulse response, which is nothing but g of t is equal to 1 by Ts into x of t plus 2 x of t cos omega st plus etc. So, the sample signal, board visible അല്ലെങ്കിൽ നിങ്ങൾ ഒന്ന് unmute ചെയ്തിട്ട് പറയണേ. Sampled signal contain components which is nothing but this is a sampled signal. This contain components which is nothing but 1 by Ts into x of t, where x of t is the continuous time signal, and we can represent the spectrum of this continuous time signal by x of omega, which is obtained by passing through an ideal low pass filter with the gain Ts. This ideal low pass filter have gain Ts and filter band which is limited to FM hertz. So the reconstruction filter transfer function we can define like this. ഈ reconstruction filter transfer function we can represent like this: 2 pi fm minus 2 pi fm. ഇത് clear ആണോ? So from this we can write h of omega, that is h of omega is nothing but this ts into, this is a rectangular function, so rect of omega by minus 2 pi fm to 2 pi fm. This is 4 pi fm. That is nothing but 4 pi fm. H of omega 2 pi fm minus 2 pi fm 0 ts. So this h of omega is nothing but this ts into, this is a rectangular function, so rect of omega by 4 pi fm. This is the reconstruction filter transfer function. So from this h of omega we can get h of t. H of t is nothing but Fourier inverse of h of omega. We get the impulse response h of t. H of t is nothing but Fourier inverse of h of omega. So taking the Fourier inverse we get that h of t is nothing but 2 fm ts sinc of 2 pi fmt. This is our h of t, that is the impulse response. Now the filter output, that is we are passing g of t through an ideal low pass filter. Now the filter output will be our reconstructed signal x of t. X of t is nothing but summation k x into kts h of t minus kts, which is nothing but summation k x of kts. H of t we have this function, so we are time shifting t here, so this will become sine 2 pi fm t minus kts. This is our interpolation formula. G of t is nothing but x of t into del ts of t, as we all know from sampling theorem. So considering the kth sample, we get that g of t is nothing but x of kts, which is this one. Considering the kth sample, when we are considering the kth sample, g of t is nothing but x into kts into del of t minus kts. So filter output g of t is nothing but x of kts into h of t minus kts. This is the filter output. So to find the filter output, this is our expression. So x of t is nothing but summation k x of kts into h of t minus kts. See here h of t is nothing but 2 fm ts sink of 2 pi fm t. So it is nothing but summation k x of kts sin c 2 pi fm t minus kts. Either this way or this way. This is our interpolation formula or reconstruction formula. That is, once again, h of omega is nothing but ts into rect of omega by 4 pi fm. Here h of t we have Fourier inverse of this h of omega, which is nothing but 2 fm ts sin c of 2 pi fm t. Here the filter output g of t, to find the filter output g of t is nothing but x of t into del ts of t. So g of, considering the kth sample, g of t is nothing but x into kts into del ts of, here considering the kth sample it will be t minus kts. So from this we can find the filter output x of t as g of t equal to x of kts. This is the impulse response, which is nothing but h of t minus kts. So here we have the formula for h of t. So substituting this, we get that x of t is nothing but summation k x into kts h of t minus kts, which is nothing but x of t this is our reconstruction formula or interpolation formula. Next we will discuss a problem. Here we have to find the Nyquist rate and Nyquist interval. We have given a signal x of t, which is 1 by 2 pi cos 400 pi t cos 100 pi t. Sorry, 4000 and 1000. So x of t is nothing but 1 by 2 pi cos 4000 pi t cos 1000 pi t. So cos A cos B formula 1 by 2 pi cos of 4000 plus 1000 plus cos of 4000 pi t, here 4000 pi t minus 1000 pi t by 2. From here we get that 1 by 2 pi cos of 4000 plus 1000 5000 pi t plus cos 3000 pi t by 2, which is nothing but 1 by 4 pi cos 5000 pi t plus cos 3000 pi t. Here the highest frequency component is nothing but, from here we get that highest frequency component is what, 5000, here it is 2 times FM Fs, so it will be 2500. Highest frequency component is 2500 and that is FM, and Fs we have 5000. That is Fs is 2 times Fm. So Fs is 5000. So Fm will be automatically 2500. So Nyquist interval, which is Ts, is nothing but 1 by Fs is equal to 0.2 ms. Is this clear? Here we have given the continuous time signal x of t is equal to 1 by 2 pi cos 4000 pi t plus cos 1000 pi t. We are here need to find the Nyquist rate and Nyquist interval. By applying the formula cos A cos B, we get that 4000 plus 1000 5000 pi t and 4000 minus 1000, that is 3000 pi t. So here we have Fs, which is nothing but sampling frequency 5000. So Fm will be Fs is nothing but 2 times Fm, which is the Nyquist criteria to be followed. So Fm will be 2500 and Nyquist interval is nothing but 1 by Ts, that is 1 by Fs, which is 0.2 ms. The simple problem. Now we will move on to the next topic, that is aliasing. There are 3 cases that we have to consider while sampling. That is, the first and necessary and sufficient condition to be followed is Fs should be either Fs should be 2 times Fm or Fs should be greater than or equal to 2 Fm. Fs less than 2 Fm. There are 3 conditions. If this happens, aliasing occurs. That is, Fs should be, the sampling frequency should be always greater than or equal to 2 times Fm. If Fs is equal to 2 Fm, this is the Nyquist criteria or Nyquist rate, and Fs, when Fs is greater than or when Fs is less than 2 Fm, aliasing occur. When Fs is less than, means Fs is less than Fm, or it means that the time period will be inversely proportional. So the time period will As Fs increases, time period decreases. As Fs decreases, time period increases. So when Fs is less than 2Fm, the time period increases. So we get the sampling, original of the sampled signal will be different from the original signal as we had discussed in the previous class. So we can discuss the three cases. First case is when Fs is greater than 2Fm. Then our G of omega will be nothing but 0 omega 2 omega minus 2 omega. So our G of omega is nothing but like this. This is the case of Fs greater than 2Fm. That is our first case. Now, the second case, that is, this is our first case. Now, second case is Fs equal to 2Fm, which is nothing but our Nyquist criteria. Here, our sample will touch each other. That is, our sample will touch each other. The third case is Fs less than 2Fm. That is, you can show in another graph. There is we can see that here there is an overlapping between the two spectrum. This overlapping of spectrum is known as aliasing. The aliasing occurs when Fs is less than 2Fm or when the sampling time period Ts increases, that is Fs decreases, that is Fm becomes small, Ts increases. So aliasing occurs when Fs is less than 2 times Fm. Here in this overlapped region, the spectrum component add that is in the sample, the spectrum component here add up each other, and hence the signal will be, the reconstructed signal will be distorted, and we cannot recover the original signal x of t by low pass filtering. Here this spectrum, this both spectrum overlap and adds, and hence get distorted signal. So the by passing this signal, that is the sampled signal, which is sampled by Fs is less than 2 times Fm. So this sampled signal when passed through a low pass filter, from the output of the low pass filter will be not same as the input signal. So the reconstructed signal, reconstruction cannot be or will not be proper reconstruction by passing through a low pass filter which is band limited to Fm hertz. So in next class we will be studying about the sampling of bandpass signals and sampling techniques. There are 3 sampling techniques. One is instantaneous sampling, next is natural sampling, third is flat top sampling.